So good afternoon, everyone. Thank you. It seems almost like a full house. For the fact that it's almost lunchtime, I'm quite honored. So today we'll be discussing a sector that is rarely discussed or represented at TMLS, real estate. Thank you all for coming again. My name is Zara, and in the presentation, I will show how we leveraged ML in multifamily real estate industry to make our operations more efficient and our lives quite a bit more easier. Let's start with a little bit about Venterra. Venterra specializes in the identification, development, finance, acquisition, management of multifamily residential communities in the US. We were established in 2001, and since then, we have rapidly grown to have a portfolio of 75 properties. What we're most proud of is the fact that we have a very strong in-house technology team. Somewhat of a rarity in the real estate sector, actually. We have built a range of applications for residents, for our investors, and also for our staff. More recently, we have started adopting and putting in production ML across our various departments. You can see some of our properties right on top. So real estate is one of the world's most productive businesses, as I'm sure everyone is aware living in Toronto. The multifamily real estate industry in particular has witnessed an increase in adoption of machine learning in recent years. We were slow adopters to begin with, partially because we lacked the data. It's a very domain-specific field, and so if you haven't captured the data, it's hard to make the models. But recently, they have been catching up. The use of ML has started to move into different sectors of real estate. You can probably see them in virtual tours, lead generations, and some other use cases you can see right here. Market valuation is an important one. Now we're able to reasonably predict where should we invest, how should we invest, and what the forecasting of that investment would be. I mentioned about data and how we were slow to start recording data. As anyone knows in this field, without data, you can't get models, and garbage in is garbage out. At Venterra, we envisioned and started collecting data 20 plus years ago. That's, again, a rarity in our field because most people started that quite recently. So we had some preemptive planning, which helped us capture and structure the data and develop pipelines that enabled us to actually take advantage of AI machine learning when the boom hit. Our strategy was better be safe than sorry. So any data that was resident or investor related or any other of our departments, we collected. It's a very domain-specific field. You can't buy the data. It's very hard to do that. How are you going to develop trends or develop models to predict what your residents would do, what their maintenance requests would be if you don't have the data? So once you have the data, you still need to clarify and identify what the best case use would be. And often, perhaps the most important use cases are that once you've developed the model to solve a particular problem, you can use that model to solve a subsequent problem and so on and so forth. That's how we went about it. The next is, again, since it's a domain-specific field, focus on your operation. There's so many vendors out there, and it's such a changing field, as I'm sure everyone's aware with ChatGPT. What was applicable last year is totally gone now. The libraries that were in and so you have to be very careful what vendors or which products you choose to utilize, because it is a possibility that 5 years later that either the vendor would be out of date or the product would be out of date. Our solution to a lot of that was sometimes in-house is the best way to go. One case study of Venterra, where we're quite proud of, and where ML has shown its most value, was in predicting renter trends and tenure tendencies. So what was the problem? The problem is, as I mentioned, we have 75 plus properties. We have a lot of residents. So once their lease ends, they leave However, the warning is not that long, so we end up incurring administration costs, repairing costs, cleaning costs, and that is not to take into account if we lose the rent. Better? That is not taking into account that if we do not find a tenant as a replacement, we also incur a loss of income. So to solve this problem, we needed to find a solution. Because if we were able to solve this problem, not only would we be able to make the lives of our marketing quite a bit easier, because rather than 2 months in advance, let's say 6 months in advance, we're able to find a tenant proactively. On the plus side, also what we could do is that let's say if we know our resident has a chance of leaving, we can give some benefits or try to change their mind. Some of the challenges that we faced were that there's considerable factors to investigate. What influences our residents' mind to stay or not stay? Some decisions are out of our control. We had to comply with fair housing policies. Let's say some factors have a significant influence in the result or the outcome of the model, but you cannot use some of those variables. And understand what the current resident behavior is, because if we can't understand that, we wouldn't be able to go anywhere. And data availability is always an issue. We had to combine quite a few factors, internal, external, how we go on about doing that. Prior to starting anything, we decided let's first understand what the current scenario of our manager's ability is in order to predict whether a resident would stay or not. So we carried out a blind experiment. In essence, what we did was we told our managers across properties, predict whether a resident would stay with us or not 2 months in advance, 3, 4, and 6 months. It was a blind experiment. They made the call, and 6 months later, we investigated the results. One of the more interesting results was that depending upon the ability or the interaction perhaps the manager had with the residents, there was an increase or decrease in the probability of their predictions. But perhaps one of the more foreseeable ones was that, let's say if you're predicting 2 months in advance, they were able to get a reasonable prediction depending upon the manager. But 6 months in advance, we had something like 36% prediction accuracy. That's less than a coin toss. So we started collecting data. We got divided into 4 larger, broader sectors: contract details, basically what the length is, what the type is, what are the habits of our residents. We had been collecting this data. It was easy to get. You just had to organize it in a certain ways, what the occupant details were, and what the satisfaction level was if they had been living with us for a few years. We combined it all. We reduced the data from approximately 120 variables to 75 plus, lots of correlation studies, and then we filtered outliers and got a great bunch of data that we thought we could proceed with developing a model. It's very important to understand why you're making the model, specifically in our domain. Our criteria was that explainability is necessary. If we use a deep learning model and can get great metrics as a result, but we can't explain to the business why a resident is staying or why they're not, it doesn't matter. That's useless. Also, the compliance with fair housing policies would be interesting. So we wanted a balance between a model that gave us great results, but also at least gave us some explainability that satisfied the business. So we went with tree boosting models, which seems to do a bit of both. You can see the model results here. So in fact, 2 months into the prediction, the model predicted very close to 100%. 6 months in the future, we still got 80+ prediction, which was more than reasonable than what we started with, 37 to 80+. That's a pretty good result. Then came subsequent questions. Do we provide these results to the business as binary or a probability? And either way, if we do provide these results, how would the business use them, and when they use them to make decisions, what would the ramifications be on the model? Because the data would have to be cyclical in a way that this does not impact the future model. Another place we used these results were to forecast our occupancy predictions. We predicted for each property what the occupancy would be 30, 60, 90, and 120 days in advance, something that really helped our operations and proactive planning and budgeting for our business. A second interesting application of ML at Venterra was identifying maintenance needs and developing models for preventative maintenance. Actually, you can see our app right there. It's pretty cool to play with if someone wants to download it on iOS. So again, we had the data. We had millions of requests. We just collated it and combined it in a way that we could predict what was necessary. To give a high-level overview, what this does is, I'm assuming a lot of people here live in condos. Let's say your dishwasher stops working. You tell your management that your dishwasher has stopped working. Most management companies would read that and then allocate resources. What we decided to do was use NLP so that it can, the whole process could be automated. When we explored the data, there was an obvious class imbalance. More requests, let's say, were of appliances than a fireplace. But the problem in its essence was a multi-output classification. We needed to predict 2 or more outputs given 1 input. In our particular case, task categories and definitions. Keeping that in mind, we developed a model that was able to give us what we need. So let's say if the resident would enter, the fridge is leaking water continuously. It would hit the model API, and in real time, you'll get an answer that it's an appliance issue and specifically deals with fridge miscellaneous. However, that's only the case if the confidence is high. If the confidence was low, then we'll say it needs investigation so that someone can allocate the right category. I mentioned in the beginning, the best use cases are the ones that if you have the results of one model, you can use to improve another problem as well. That's what we did in this particular case. Now that we could predict what the task categories were, we were like, let's try forecasting them so that budgets and resources could be planned accordingly. If we know what the HVAC, total requests would be in a year, that would help our business quite a bit. Same with appliances, resources can be allocated accordingly. We again had 20+ years of data. This was one of the few problems that we've encountered where we did need a complicated model. One of the major reasons being that some of the properties that we acquire didn't have enough data. So we needed a model, a global model that could utilize data from one property and also figure out the similarities between the properties and apply it to another property that had less data. So basically, zero-shot predictions. You can see the model overview here. We had different properties. That's what the first column dictates. We combine the different properties into different stacks, which constituted of different blocks. Then we produced a multivariate output. So we were able to predict not only what the number of maintenance requests were, but what the predicted amounts would be and what the time and effort would be a year in advance. Obviously, the business would be less interested in graphs, so we gave them in a way that made sense to them. We gave them in a dashboard that gave them survival curves and the one-year predictions incorporating seasonalities for different properties and in totality. I'll end the presentation here and happy to take any questions. Yes, please go ahead.
Yeah, what is the accuracy?
Of which model?
What is the accuracy of your model?
The renewal one?
Yeah, for forecasting, yeah.
The forecasting one.
Yeah.
We were able to go to, depends upon if it was maintenance requests, budget, or which specific one. For the maintenance request, we were able to go to about 85%.
How much?
85%. Yeah. Yeah, please go ahead. Yes.
Yeah, I was just wondering maybe on your experience on making the business partners buy your model or apply it or find it useful for their case. How did you handle that?
Sorry, Sandra, can you come a bit closer? I can.
I'm just wondering on how did you handle the relationship with your business partners so they find this useful or actually applying it to the business cases?
Well, that's a good question. So I think it's a process in learning. You continuously talk to the business to see what they want, have them involved from the beginning so that when you have a model, you know exactly how to put it in production. You also have to keep into account the technical acumen of your business. What would help them? Is it numbers they're looking for or just a general trend? So I think we approach it using that.
Thanks so much for your presentation. It was very interesting. I did have kind of a bit of a minor question to ask you. So for the box plots, the slide where you had the box plots and you're just talking about the accuracy of the supervisors or whoever it was, what was the sample size of the people that were involved, like when you were creating the box plots?
For the properties, you mean?
Sorry, what did you say?
For the properties?
Yes, like just the box plots. What was the sample size that you used to make those box plots?
So we used 2 per, so we have properties in different regions, and we had a few variables to consider. Managers with different experience, and managers we gave the renewal rate to or not. So it ended up being about, in totality, I guess, about maybe, if you considered all the variables, maybe about 16 variables and combinations.
Okay, no, I mean, I'm just asking about the box plots because...
So when you say the box plot, let me go, this one?
No, the plots that look like boxes and they have error bars. It was a couple slides. No, it's the one, it's still a bit before that. Yeah, it's this one. Yeah, so I can see that the spread of the box plots along the x-axis, like each of those boxes are pretty large. Mm-hmm. So that's why I was just curious, what was the sample size of the people that you interviewed or asked or whatever for this part?
Oh, this is just it's just for display purposes that I made it larger. It wasn't because of, it doesn't indicate the sample size, but the sample size was taking into all variables into account. So it was 2 per region. So I believe, if memory serves correctly, it was 16 in total.
Okay, so you sampled only 16 people.
Correct. Yeah, we have 75 properties. That's a decent sample size. Yeah, you have doubts about that. Yeah, we can take this off. Yeah, we can take and have a discussion why we specifically decided to go that route in detail after the thing. Yeah. Mm-hmm.
So when you're forecasting your maintenance predictions, how do you compare the properties while training? Because every property is going to be different. What, the brand names of, of the appliances and everything is going to be different. It also depends upon the workmanship.
Yeah.
So how did you solve that problem on getting all the properties in one level where you're able to use the data set to make any predictions in the future?
Are you talking about forecasting or the initial?
The forecasting.
The forecasting, yeah. So we did train the model separately for each property because that is the case. But in certain properties, we did not have enough data. So the model had to learn that, okay, this property is similar to that property and within the same region with the same problems. So there we had to kind of teach it to get data from another property. But in essence, we did teach it property-wise, because a property in Florida will have a different type of maintenance request, probably more flooding, versus something in Texas. So that was considered.
So what features did you use to kind of rationalize the model from one property to the other?
Okay. So there was actually quite a few. The location was a major one. What we also used was the requests that we were getting, what are the totality of the requests were for each category. We had summed those up. We were also taking into account what the budget forecasting was for each of the scenarios, how were we allotting that. Also the number of residents, the number of units, what type of property it was, other features regarding the property. So that's what we were, I guess, property details, resident details, and combining them, and then seeing trends within each other.
Okay.
Yeah, I'm just wondering, have you encountered any outliers or skewness in your data? And if yes, how did you deal with those outliers?
Oh, that's always, yeah, that's an interesting question. Yes, always. It depends upon the use case. Like in the case of the renewal model, we decided just to take away the outliers. There were few, and some things just didn't make sense. So in that case, we just decided to take it away. In case of the maintenance predictions, it was NLP, and we had a lot of data. So while the outliers played a part, it didn't as much. And one outlier in that particular case we encountered was if the request came from a resident versus a staff entered it, the way the text is entered is different. So we kind of had to make separate models for each case and then combine the result together as one out.
Okay. Thank you.
Yeah.
So did you just explore only tree-based models, or did you explore models like logistic regression or something like that?
You're specifically talking about where we
The model building part, the first model that you were talking about.
Yeah, so for that particular, no, we started with simple. That's always the way to go, right? You start with the most simple model, see what you get, and then go more and more complicated models. So we ran the predictions for all the cases with smaller sample size and understood what were the general metrics we were getting and what we could expect if we ran it in its entirety. So yes, we investigated from the simple and then reached to tree-based. It's just that amongst, I guess if we didn't go into deep learning and all the other models we explored, the tree-based models just gave us the best result.
Right, and were you also exploring or trying to extend it to new property sales?
Sorry, two?
New property sales. So you were talking about renewals.
I see, okay. So in that particular case, no, because when we have a property, the case of renewal would come up a year in advance, a year later, right? So we would have some data before we need to make that particular, I guess, prediction. Whereas in the latter cases, when we're trying to forecast right from the first day, we need to forecast what the budget would be or what the maintenance request would be. But at least with the renewal, while there is some applicability, we did, it was easier to predict because the data, it's similar things that were resulting in, let's say someone renewing or not. Let's say if someone has bought a house and they have to leave, it's same irrespective of where the property is. Does that make sense?
Yeah, got it. Thank you.
Hi, thank you for the presentation. I have a couple of questions concerning the maintenance predictions. If I understood correctly, you build some features based on maintenance descriptions, or my AC is broken, and so you need to predict that category is electrical or something like that. I'm sure you encountered many cases where few things were broken in the same descriptions. So how do you deal with separating all the categories together? Does that make sense?
I'm not sure if I understood.
So if I say, okay, my AC broken and also some of the lights and my toilets are broken too. So I may have electrical problem, you may have plumber.
So that's where the low, if you recall initially what, okay, it's closed. One of the things we said was if something's of high probability, you'll get a result, but if something's of low probability, and this is one of the case scenarios that someone has, let's say, a few issues given, it will result in no, it wouldn't give an answer. It would basically point it to someone from the staff to make the accurate, allocate it to the accurate category, and then they'll break it into two and then allocate it accordingly. And this was one of the case scenarios.
Okay, and did you use some sentiment score also for those kind to see, okay, this person is angry, maybe there's more.
Yes, we did actually. Yeah, that's one of the projects we did. Like generally for survey and any requests we get, we assess if what we allocated between 1 to 5, what the sentiment score is, and just so that we are aware, like which also plays into the renewal model, that how happy or angry has the person been in our dealings with them.
Thank you.
Any more questions?
Hey, thanks for the presentation. Two questions. First, for the deep learning models that you used, how often would you incorporate like a fine-tuning of the model based on, like, I think it was used for forecasting, but how often would you incorporate fine-tuning based on actual results that come up in the real world? Second question was I'm just curious, like for the maintenance model, for example, like what was the added value? Like how much, was there a net benefit of predicting what sort of maintenance was required over like a human just reading those complaints? Because I don't imagine like the company getting too many requests at the same time, right? So was it more of a research project, or did it actually have a lot of added value because of the volume of requests?
To answer your second question first, the latter, because if we have 1 million requests, you can imagine how many, like, I think that's the most common way a resident interacts. They have some issues, so there are a lot of requests coming in. To answer your first question in terms of retraining and fine-tuning, if a new property is added in the portfolio, which happens frequently enough, if that doesn't happen for a long enough time, probably around 6 months.
Thank you.
Great project. I have a question about the first use case. I'm really curious to understand more about the explainable AI component. Can you elaborate a bit more about what were the top features that determined if a tenant would stay like long-term, 6 months or more versus like short-term?
Yes, actually, I did have a slide on that on the appendix, but I think we've just taken that down. So one of the ones was basically the number of years they've stayed. So this was one of the factors we can't play with. People usually, in the states that we're interested in, or we have properties in, people usually move after a certain number of years if they're buying houses. So that was one. Another was kids. If people have kids and if there's a good primary school around the area, they're going to most likely stay till the child graduates from that primary school, same with secondary school and so on. Others were maintenance requests. How frequently are we actioning them? And also which maintenance requests. There's some things that make people more angry than others. So their sentiment score. So there were quite a few. I think we had, there were 10 ones that had very high correlation. The other was, it depended on the property. Appliances. Appliances are a common one. It's seasonality-based. HVAC issues are depending upon the season. That's a very common one. Again, if some of our properties are in Texas, so if you were in Texas when the snowstorm hit, I think for about 2 months, all we got was regarding that. So there's a lot of factors that come into play, but the number one is appliances. Thank you.